Welcome to this overview presentation on discretization of PID controllers. We will talk about importance of discretization, Ziegler-Nichols method of tuning of PID controllers, approximation methods. We will talk about 2DOF controllers. Aryabhata's identity will be solved in Scilab, sample problems solved and simulated in Scilab. This overview lecture will give a feel for these topics to be covered in this week. One may already have continuous time controllers in Laplace transform. If not discretized properly for implementation purposes, controllers will not work properly and extensive retuning of these controllers may be required. A good grounding on discretization is required. This is what is expected to be done in this week. Here is the standard PID controller and we will talk about Ziegler-Nichols tuning. Two methods are there, one is reaction curve method, the other is instability method. Both of them will be covered in this week. We will also get an approximation of continuous time controllers using the step response equivalence approach, the formula for which is given here. We will also introduce area equivalence approximation for discretization. This method will involve finding the area under the curve, namely integration, in continuous time and in discrete time. We will present different kinds of approximations and their pros and cons. We will introduce a 2DOF controller, 2 degrees of freedom controller. To arrive at the control law given here, here is the schematic of this control law. SC by RC stabilizes the loop, it rejects disturbance that comes through Y, and TC by RC helps track the reference signal. We will derive the conditions for offset free tracking of steps in this 2DOF configuration. We will point out some of the practical implementations of PID controllers. We will discuss bumpless transfer. We will show how to avoid set point kicks, and we will introduce the notion of dynamic pre-filter. We will consider Aryabhata's identity for controller design. Aryabhata's identity is given here. This is a polynomial equation. Such equations arise naturally in control design problems. We will implement these algorithms in Scilab. We will solve and simulate in Scilab. This gives an overview of the topics to be presented this week. I hope you will join those presentations. Thanks for joining. Goodbye.